So we're gonna do the first 4 slides today, and then on Monday we'll finish this up, and then we'll learn new stuff on Tuesday and Wednesday next week, and then Thursday you'll have like a practice. Oh, the parallelogram sheet? Okay. Anyone else not have this? And then next week, Thursday, we'll have like a practice quiz / test. And then next Friday will be the actual quiz or test. All right, so if we look here, today what we're gonna do is talk about rectangles. And one thing that you guys are gonna notice by looking at this sheet right here, so we spent 2 days on parallelograms. So on this cheat sheet, on the front, everything that is on this cheat sheet, AJ, everything that's on this cheat sheet, we are going to, it has every property of a parallelogram. So everything that we have learned about a parallelogram, a rectangle has, a rhombus has, and a square has. That's not the case on the back. And the back I don't think we'll get to till after Christmas break. I think this next week we'll get through the front page, okay? So a rectangle that we're starting with today has every property that we already know of a parallelogram, and then it has additional ones also. So the first thing that is true about a parallelogram is that it has 4 right angles, and you guys have probably known that for how many years now throughout your other math classes. So what we're gonna do today is talk about a couple additional things about rectangles that you don't know, okay? So in a rectangle, like I said, every property of a parallelogram is true, okay? It has the 4 right angles. And then if we come down here, this right here is gonna tell us 2 different things. First thing that it tells us here is that our diagonals are congruent. So this whole diagonal is congruent to this whole diagonal, okay? What I'm going to do, I think, is erase that now, and then I'm gonna have you guys write something on your actual cheat sheet where it has the drawing for the rectangle. What I would like you guys to do is draw the diagonals for that rectangle, okay? So on your cheat sheet, go to the rectangle. This will help you a ton, so if I were you, I'd definitely be doing this. Draw the diagonals, and then what you're gonna do, in a rectangle, all 4 of those pieces are equal. That's gonna be a huge part of what we talk about today. The other thing that I'm gonna have you write off to the side for this one is that the whole diagonals are also congruent. Okay, so not only are those 4 pieces congruent, but the whole diagonals are congruent to each other. Both of those things are things that we're going to use today. Okay. Another thing that we're going to use today is this. So in that same diagram on your cheat sheet, do you guys see how these 4 angles are the same? Can you please mark those 4 on your cheat sheet? Okay. Mark that these 4 angles are equal, and then mark that these 4 angles are equal. Okay. Those are things we're going to use a lot. So these 4 pieces are equal. these four angles are equal, as well as these four angles are equal. And then we talked about the whole diagonals are congruent too. So if I were you, I'd have that whole thing right here on your cheat sheet. Okay? Everybody good with that? All right. So let's go here. This problem says that the measure of angle 1 is 37. And what they want us to do here is find other angles that are missing. So talking about what we just learned, is there any way I could find angle 2? Because these add up to what? 90. So do you get angle 2 would be 90 minus 37, which would be 53? Okay. Now, do you remember how this angle, this angle, this angle, and that angle are equal? So if that's 37, aren't all four of these 37? Okay. And then we know that this little angle here is congruent to this little angle here, which is congruent to that angle, which is congruent to that angle. So if we found that this one is 53, that makes this 53, this 53, and this 53. Okay. Now, does anyone see a way that I could find either angle 7 or angle 6?
If you're 53 plus 53 plus angle 7 equals 180.
Yes. In this triangle, they would add up to 180. So if we added, and you don't have to show your work for this, but if you added 53 plus 53, that's 106. And if I subtracted 106 from 180, that is 74. So angle 7 is 74. Now, there are two different ways now that we could find angle 6. Does anyone know one of them? Yeah, Isla? Yes, that is probably the quickest way that you could do this. These two angles right here form a straight line, so they would add up to 180. So if this is 74, the other one would be 180 minus 74, which is 106. So that's 106. The other way you could have done it is use this bottom triangle and went 37 plus 37 and subtracted that from 180. So if we go here, angle 2 is 53, angle 3 is 37, angle 4 is 37, angle 5 is 53, angle 6 is 106, angle 7 is 74. So that is the answers. Okay. Now if we go to this page, this is just going to give us different scenarios, and we have to figure out how we would find this out. Okay, so they're telling us here that BE is 6y plus 2, and CE over here is 4y plus 6. Do we know something about those? They're equal. One of the things we just copied on your sheet is that these four pieces are equal. So what I would do there is just say 6y plus 2 equals 4y plus 6. Now we're going to bring that 4y over, so we're going to subtract 4y. 6y minus 4y is 2y, plus 2 is 6. Then I'm going to subtract 2, and I get 2y is 4, divide by 2, and y is 2. Okay? And that, they just wanted us to find y. Now in this one, they say angle BEA, okay, BEA, which is this angle right here, is 62. And they ask us to find angle BAC right there. Anyone see anything?
180 minus 62 divided by 2.
Yes, because this is x, we would know that's x, because remember these 4 angles are equal. Now we have this triangle, and we could either go x plus 62 equals 180 and solve it algebraically. Or like Grace said, you could go 180 minus 62, which is 118, divide by 2, which is 59. So the key there is knowing those 2 angles were equal. If I do it the algebraic way, I'm going to get the same answer. So I'm going to subtract 62, and I'd get 2x equals 118, divide by 2, and x is 59. Okay? Then if we go down to this one, it says angle AED. AED right here is 12x. Okay? Then it says BEC is 10x plus 20. What do I know about those 2 angles? They are equal because they are vertical. Very good. So I can say 12x equals 10x plus 20. And then I can go ahead and solve that. So I'm going to subtract 10x. Okay. 12x minus 10x is 2x equals 20. Then I'm going to divide by 2, and x is 10. Then in this one, what they want is the measure of angle AED right here, and that's the 12x. So the measure of angle AED is 12x. So you can take this 10 and put it in there, and you're going to get 12 times 10, which is 120. So you have to show this work for the measure of angle AED. If you can just put that in your calculator and write it down, that's fine. Okay. All right. Now if we look at D, it says that BD, which is this entire diagonal, okay, is 8y minus 4. Then they say that the other diagonal, AC, which is this one, is 7y plus 3. What did we say is true about the 2 diagonals of a rectangle? They are equal. So we can just say 8y minus 4 equals 7y plus 3. And then we can solve for y and then put it back in to find what they're asking for. So if I go to solve that, I'm going to bring my 7y over. And I get y minus 4 equals 3. Then I'm going to add 4. And y equals 7. Now I'm not done yet because what they're asking me for is BD. And BD is right here. It is 8y y minus 4. So I'd put 7 in here, and I'd get 56 minus 4, which is 52. Is that what you guys got too? And if you ever wanted to check, you could put the 7 back in here and go 7 times 7, which is 49, plus 3, which is 52. All right, now let's go to this page. And we have another rectangle, and this one says DAC, which is right here, is 2x plus 4. Okay? And then BAC, which is right here, is 3x plus 1. What do we know about those two angles if it's a rectangle? What do you know about all these corner angles? They are right angles, right? So if this is a right angle, what I can do then is just say 2x plus 4 plus 3x plus 1 equals 90. 2x plus 3x is 5x. 4 plus 1 is 5, and that equals 90. Subtract 5, and I get 5x equals 85. Divide by 5, and x would be, is that 17? Okay, and then what I can do here, I have to find the measure of angle BAC, which is this. It is 3x plus 1. So what I can do is take this 17 and put it in here. 3 times 17 plus 1, which would be 51 plus 1, which would be 52. And then you could always put 17 into the other one, which is the 2x plus 4. So 2 times 17 would be 34 plus 4 is 38. And 52 plus 38 does equal 90. Now if we look at this one, it says the measure of angle ABD, which is right here, is 7x minus 31. Okay, then they say angle CDB right here is 4x plus 5. What do we know about those two? Remember that these have all the properties of a parallelogram? Didn't we talk about the fact that these then would be parallel? And what kind of angles are those? Alternate interior, right? So we can say 7x minus 31 equals 4x plus 5. So you have to remember in this one that this has everything that's true about a parallelogram. So now I'm going to subtract 4x, and I get 3x minus 31 equals 5. Then I add 31, and I get 3x equals 36. Divide by 3, and x is 12. Then the last thing I'm going to do is find the measure of angle ABD, which is this one right here, which is 7x minus 31. Did anyone happen to punch that into a calculator? 84 minus 31, is that 53? Thank you. All right, so your assignment then is this. And if you wanna move around and work with someone, as long as you're working and as long as you're not disrupting others, you can. You guys, I still have a page 329. And then I still have two section 4-3 day 2 worksheets. So if I were you, I would check my Skyward and see if you were missing any of these.
Where's the?